There's a lot of talk about compostable, biodegradable materials, and then the use of the term bio-based or biopolymer. Could y'all kind of share your opinions of the use of those terms, and also getting into things like saying green and eco-friendly, and what really is the best way to refer to these materials? Go.
There, now it's on. Okay. Bioplastics is typically defined as either bio-based or biodegradable, which is terrible. So my recommendation is never call anything bioplastics, because no one will know what you're talking about. Biodegradable itself is almost as bad. Compostable is defined. There are standards, so we can talk about something being or not being compostable. Biodegradable without environments or time frames is similarly meaningless. Polyethylene will presumably biodegrade eventually. It will probably take thousands of years. Certainly it will take longer than polyethylene has existed. So so my opinion, when companies are throwing around those words, they're trying to sell you something that probably doesn't work. So I've probably said enough.
Let me check. Several years ago, I used to attend like a bioplastic, biodegradable conference. And I think if you look at the term biomaterial or bioplastic, maybe it's some kind of thing that a plastic manufactured using the raw material from the biological system, like a biosystem. I think, if I don't recall wrong, they have for example, polylactic acid. That's the one that considered as a bioplastic. Actually very similar to a polyester material, and that's why it can be replaceable. And in terms of biodegradable, I think in terms of biodegradable, it could be degraded by light, okay? And that's why sometimes the term photodegradable, that come into play as well. And I don't know, in terms of bio, maybe dealing with the environment that consists of maybe oxygen and the bacteria and also light. That could be a factor that really digest or degrade the material. And I agree with Dr. Selke, okay? Anything, it depends on the time frame. That's why I think the compostable material, they have some kind of standard. That means you have to certain some kind of thing, I don't remember the detail, but it describe the condition in such a way that the material will be decomposed within certain short period of time, not 1,000 years like a polyethylene, as Dr. Selke mentioned. And I think that what I learned from the conference is, I'm not talking about on behalf of the FDA, okay? That's my personal opinion. Thanks.
Well, I think there is some differences in the practical definition and scientific definition. Bioplastic the definition scientifically, as Dr. Susan Selke said, it originally came from somehow the biomaterial. So it could have at least 20. That's the USDA guideline. I think some of you came from USDA. Bioplastic definition from USDA is 25%, more than 25% bio-derived material is in the structure, then that is called bioplastic. So that's the reason why the plant bottle, the Dasani, the plant bottle is called bioplastic. It's a scientific terminology, but again, I totally agree with Dr. Susan Selke. There's no reason to separate. I don't know why they are calling it a bioplastic, because it came from biomaterial. But again, there is no the clear the message about in bioplastic. That's my opinion. Yeah.
Want to just make one additional comment to that. The Federal Trade Commission also has their green guides, and it does give some guidance to those trying to talk about what the materials are and not misleading the consumer. And the FTC has done a bit of a crackdown on companies claiming biodegradability, particularly because of time frame, location, and the presumption of where your package will end up to meet that definition versus where it actually ends up, perhaps in a landfill without those emissions.
Yeah. Another quick addition to that is there's maybe a place for everything. Okay, where is the door? And just to add to what Rachel said, I think there's also a place for compostability, but not in every case. For instance, you could have a PLA-based bottle for water. Doesn't really serve any purpose. I mean, you're taking something that's fully recyclable, which is PET, and now introducing something that really can't be recycled in the current recycling stream. So, and that's one of the reasons that NatureWorks, the company that makes the PLA, got out of the bottle market because they realized that that wasn't the right application. So I think it's very specific to the end use, and my personal feeling is compostability should be sort of the last resort, not the first one. If you can recycle something, that's the most ideal situation.
My question is somewhat related to the FTC, but I'm hoping that maybe you can make a comment. It sounds facetious, but I don't mean it to be. Looking at phenolic resins, they're made by combining phenol, which your body produces. Your body produces almost every cell through natural biochemistry, produces phenol. It's combined with formaldehyde. Many people don't realize it, but your body also produces formaldehyde, all naturally. As a fact, each breath releases more formaldehyde than what the EPA regulates at the line of a factory. But anyway, with that in mind, could we call phenolic resins all natural?
Consider the source material.
Yeah, that's really the answer, is if you are getting your phenols and your formaldehyde from a biological source directly, you could. But if you're not, you can't.
Then it would be of animal origin. We would come up.
Actually, there is existing natural phenolic resin. One is called, our former the faculty, he retired around 7 years ago. His name is Dr. Wolfgang. He is an expert in the lignin area. He polymerized the lignin to produce like a plastic resin. Then he produced a bag. Actually, he opened his own business using that materials. So I think that's the one of the example of natural phenolic resin, because it's coming from the phenolic compound. The lignin is composed of plenty the phenolic materials. Do you know the problem of lignin, the phenolic material? During manufacturing process, it may form a formaldehyde a lot. So actually, I don't trust the bag and the resin.
We've actually touched on this a couple of times, and it's actually a third question here on our slide to the right. We're combating a lot of issues with sharing very complex scientific information with the communities around us that are purchasing, or from a brand owner's perspective, purchasing our products. And one of the things that Dr. Selke brought up was the sort of cost of recycled material and whether or not it's really like cost effective to do a certain thing, where we're combating customers that really want to move back towards glass because it seems more ecologically friendly, but they're not necessarily taking into consideration how expensive it is to kind of do that. and the carbon footprint that kind of comes with that and all that stuff. So the question here is just, what are the challenges, and is there a way that, that we can kind of share this type of complex knowledge with our communities besides blogging? We've mentioned it a few times. But do you guys, has something come to mind for you guys on how to properly communicate without drowning them in information? No.
The environmental journalism program at Michigan State is putting out a series of videos about basically how to talk to non-scientific audiences about scientific topics. They're, I believe, freely available on the website. It's a work in progress. They have the third one, I believe, came out this morning because I got an email thing about it, but I haven't looked at it yet. The first two were like 3 minutes apiece. Pretty basic but useful.
Now, actually, this might be one of the situations where, you know, NGOs, consumer groups might actually be useful. The whole idea of, you know, product life cycle assessment is something that is becoming a little bit more mainstream. People are becoming more knowledgeable about it. And, you know, if these organizations truly are worried about quote-unquote sustainability, focused education of those types of organizations might actually be of benefit, and you know, they use them to get the information out. I mean, if they, you know, they're truly worried about sustainability, you educate them on sustainability. They might actually be helpful.
Hi, my name is Sunil. So I am referring to the third point here, right? We are discussing. So I'm a food scientist from Los Angeles, and if you don't know what that means, is that if I reveal that information, I probably need personal protection. So, so I mean, I have been battling with that last bullet point there, right? I mean, I raised this question during several IFT meetings, and I asked experts why the Time magazine or, you know, Washington Post or somebody is not coming up with our story. You know, they always go to the other side. And one of the suggestions to me, I mean, I teach too. I mean, I teach a class on writing. I give them popular writing assignments. Why can't the organizations here, right, ILSI or FDA, I think we need to have a completely different section, blog, in a different language, you know, in a language that, you know, a lay person can understand. And it's all about Google search. You know, when we hit a topic on Google for search, the general public, they go with the first 3 searches, and if you look at it, it's probably the food baby or similar kinds are popping up, right? FDA goes probably the last, ILSI go the last. So I think probably these organizations, federal government agencies and other nonprofit agencies should be looking into developing or even, you know, hiring people to write about science.
I want to make a comment. You know, the FDA is a science-based agency, so whatever you make the decision, we base on the sound science, okay? On the other hand, when you try to communicate with the public, we try to use a plain language. But again, it's plain, I don't know they understand or not. We understand because we are scientists. And that's the kind of thing that the agency is moving in that direction. All the document, any information, we try to really make sure that, you know, we communicate directly to the public using the plain language. Hopefully they understand better. And that's the kind of thing that is our goal, to indirectly or directly communicate with the public using simple explanation, not too much science or terminology, scientific terminology, those type of thing. And I give you funny thing, that's a story. I have friends, who ask me, say, well, they read the information on the internet, the PET bottle, when you put in the car for a long period of time under the hot sun, it will generate some kind of cancer compound. And they say they mix it with some kind of phthalate. And I explained to my friend, well, the PET bottle is a polyethylene terephthalate, okay? And they cut off the first portion and look at only the phthalate part. And that phthalate has been some kind of very, the plasticizers associated with a lot of implication of the health effect. And that's kind of thing the consumer, when you read that, they just kind of thing maybe not fully understand, the key element, and they grab information from the internet, and internet information, a lot of them is quite really not truthful information. And that's the kind of thing, as a consumer safety officer, sometimes, I get a phone call when the customer, asks about a question, and I try to explain to them, to them about what's going on, and I think they appreciate it. We try to educate them, and we have the email and also the hotline they can call, and so we can really explain, something they don't fully understand, and that would try to help.
So, a couple ideas, maybe. One is, don't act like a dinosaur. I think blogs are dead, but social media is alive. We need to look at where the young generation is getting their ideas and use the modes of communication that they use to communicate to them, because that's where the ideas are being formed, whether they're right or wrong, based on fact or misinformation. So maybe we ought to think about how to communicate to the up-and-coming generation, the next generation, to build the idea of good fact-based informed decision-making versus emotional-based decision-making, because I think that's what's driving a lot of the emotionalism. So just a thought of how do we engage there, and how do we challenge maybe some of the students to say, how do you get the word out and have them be the voice piece? If it's industry and maybe government being the source, maybe it will be looked at as not as credible as some independent organizations. So that's a question to think about, to say, I remember CMA going back when the chemical industry was like one step below terrorists. Do you guys remember that? In opinions. And they said, how do we improve the image of the industry? And right now, I think the credibility of government and industry needs to be looked at and said, how do we build that back up? And just some thoughts on that. And so then I have a totally different question. With the focus on compostability, preservative-free and organic foods, et cetera, any concern, and use of recycle, any concerns with the absence of preservatives in food and the combination to say, do we have a perfect storm to brew microbiological events because of the packaging scenarios that we're facing today?
I don't know if we have necessarily, and that's one of the good things about food packaging is that, you're not necessarily going to see a public health issue as far as microbiological contamination, although for certain things you can, but the bigger thing that people are going to have to realize is people are used to, buying bread from the grocery store, and bread being mold-free for 2 weeks after you buy it. I think what's going to happen is if the type of sentiment that you're talking about against preservatives, or just as an example, you're going to go back to the days where your bread's only good for a day. And if you wait a day, it's going to have mold, and people are going to say, well, why is this happening? I remember when I was a kid, You could buy mold and it wouldn't go bad. You could buy bread, it wouldn't get moldy for 2 weeks. Well, that'll be the answer. Maybe that'll be what it takes. I don't know.
Dr. Kim just mentioned that use the nanotechnology and nano materials be used in food packaging. And my question is that does FDA has a special assessment for this kind of material to be used in food contact material? Or is there any special concern if this kind of nanomaterial, such as nanoscale titanic dioxide, or nanoscale zinc oxide, or nanoscale silver, can be incorporated in packaging material and use food contact materials?
I'm honest with you, as a scientist, I'm not toxicologist, so once we develop it, we may pass it to other toxicologists and they will investigate it. But so far, these new materials are really new, so I never heard about like bad things so far. But like for example, nano silver, I have seen a lot of the study. It might carry some like a toxicological problem, but regarding titanium dioxide or the clays, I never heard about any like a bad the concern. So that's the reason why we are working on some like some safe material first. Then I mean, so far we don't use some toxic material at this moment, like a heavy metal or the zinc oxide. We don't use it at this moment. Not only for the price, because we don't know the toxicological things. So, but as a scientist, yes, we are still interested in new material. But once we develop it, once we some functionality, then more study must be done for solving the toxicological the concern. Then that's my opinion.
And from an FDA standpoint, we don't have specific guidance for nanomaterials. Mainly, it's if a material is actually engineered to be nano for a specific intended technical effect, we encourage companies that want to use those in food packaging to come and talk to the agency so we can, oftentimes there'll be specific, maybe not really concerns, but factors that need to be considered for that specific nano material. So we wouldn't necessarily have generalized guidance for nanomaterials, but would more deal with them on a case-by-case basis. So we would just say that if anyone is working on nanomaterials, come talk to us.
So I've got actually my own question for the recyclability and recycling and how safe it is for my other panel members. I'm dealing with packaging food safety, which means we don't want any icky nasty chemicals going into the food. And when you compare recycled paperboard to virgin paperboard, you find things that are not supposed to be moving into the food. The RPTA, Recycled Packaging or Recycled Paper Technology Association, puts out a white paper that liberally quotes 176-260 as something that they are testing for PCBs and phthalates and et cetera, heavy metals, whatever, which is completely opposite to packaging safety that says you need to minimize or eliminate them. So that's one point that I'd like you guys to maybe think about and comment on. And the other one is they won't say how much they have. The 176.260 says that they're responsible for ensuring, et cetera, they're responsible for periodic testing, but it does not say in the letter of the law that they must share that information. So safe levels, it's a gray box for an end user such as Nestle. And maybe you could comment on that, if possible.
As you are aware, 21 CFR 176-260 is more like a qualitative. it's no quantitative measure. I mean, how low of that potential migrant that could be potential harmful to, in case it migrated to food. But I think the rec clearly state that, okay, if you have the material that contains some kind of potential toxic substance in there, and you got to ask the question that you're going to use that as a source and then recycle it for food contact application or not. You got to control the source, okay, or otherwise you have to develop the process in such a way that you remove the contaminant level to the level that no safety concern. And actually, as a matter of fact, I didn't mention in detail because I have limited time to talk, about the paper recycling. What I have learned is in the very few paper recycling submission that we have received, the company addressed about the potential contaminant in their submission. And they try to demonstrate that that process is very effective, or the way they use the material, it would not pose the safety concern, and based on the 0.5 part per billion dietary concentration threshold declaration. And that why, very few companies submit the paper recycling submission based on that threshold limit. And some other company come forward in the past probably, they try to really discuss with us how to really recycle that paper, and they discuss with us, and we recommend them some kind of surrogate testing similar to the plastic recycling process. And then they said they didn't want to do it. So that's why a lot of them, they didn't submit the paper recycling to us. And I don't have the detail in terms of, the paper trade organization in terms of white paper. I didn't look at because, pretty much because we are quite overloaded about the plastic recycling already. So we didn't really consider paper recycling, consider high priority based on the number of interests of the submission that come to us. So, but again, it's the full responsibility of the person who uses or recycle the paper or the plastic, likewise. They have to make sure that the recycled material is safe, okay? And they can calculate based on the 0.5 part per billion dietary concentration. And that normally when someone comes forward, we recommend them, you have to demonstrate it. But in the case of paper recycling, it's quite really challenging because, they don't have the some kind of pilot scale to do experiment. They have like a big repulping factory or whatever process in order to intentionally add some contaminant in there, and they're going to contaminate their whole processing line. And that's the kind of thing they say, no, they didn't want to do it. And that's the kind of thing, we didn't have many paper recycling submission that provide the same type of the data we recommend for the plastic recycling. And that, the key, I think, and I think that the paper trade organization or association probably develop some kind of white paper to recommend their members or whatever, but again, I would recommend if they have any questions, they come forward to discuss with us so we can provide some additional guidance or whatever. If they don't come, we don't know what they have any kind of question.
Well, if I could briefly add to Vanee's discussion. I mean, I guess one of the questions that FDA would have for industry is how are you using these recycled paper products? It's our understanding that most recycled paper products are not coming into direct contact with food. Most paper products that do come into direct contact with food would be virgin paper stock, but also that most of the types of foods that come into contact with paper, be it recycled or not, where paper is used directly in contact, are going to be what FDA terms non-fatty dry foods. And based upon the type of food that we're talking about, there's a very limited possibility for normal diffusion migration to occur other than, for example, the ITX issue where we had a volatile component that came out of paper packaging into the food. So by the nature of the applications, for most of these, there's a limited possibility for migration, at least compared to, for example, plastic packaging, which would be more used in contact with either a highly liquidy food or highly fatty food, where that migration would be expected to occur at a higher level. So I think it would be of interest to FDA to determine if recycled paper is actually being used in applications where migration would be expected, other than, for example, a volatile component.
I think I just recall that when I was at working in the research laboratory back more than 20 years ago, I helped one of my coworkers who developed a project on the use of recycled paper in food contact application. And he applied the concept of the functional barrier. And he used polypropylene as some kind of food contact layer. It turned out that if you fabricated that kind of paper structure with the functional barrier, yeah, you can use it. But the thickness of the plastic layer that prevent the migration of the contaminant from the recycled paper layer across into the food has to be thick enough to prevent the migration that result in a dietary concentration at the 0.5 part per billion. And that's the key. You can design it. And as Paul said, paper by nature, you cannot use it for liquid. It's not going to hold it, by nature. So that's the key, that, it will limit on certain structure of the paper, in order to use it in contact with food, especially liquid.
Okay. I think just for the sake of time, we can continue the discussion off the stage. But can I get a round of applause for our panel here? And with that, we'll start closing up the meeting. Just want to big thank you to the LC team. This has been a fantastic meeting. To me, there's two indicators for a good event, workshops in general, is the amount of time that it takes you to get everybody back to their seats, because they're engaged in actual conversation instead of on their phone and doing email. So a lot of engagement and a lot of really great discussion with everybody. So I do appreciate everyone coming out and sharing your wealth of knowledge and your experience within the market.